Good morning. Good morning. It's Gabe, the O-Scope Wizard. I'm glad to be back. It has been a few days since our last episode where we are working on our DIY wireless subwoofer in a bucket. It's getting closer. On the last episode, we got sound out of it, and it actually sounded pretty good. We got it synchronized to our amplifier that we built, all to go into my driveway eventually. Hopefully the bucket will be buried into the ground and just a little bit of a port will be sticking up. Anyway, sound is happening. It's all synchronized. Hopefully we can make it sound even better and be synchronized a little bit better. We're going to work on that today. We are also going to work on putting all the different components into some sort of a container. And that is where I want to begin. So I am the O-Scope Wizard. I am not the container maker wizard or the 3D printer wizard, although right behind me I do have a 3D printer. And we're going to talk about 3D printing a little bit today. I am terrible at 3D printing, but I have made some attempts. In fact, I've made bunches of attempts. I think we should probably set up the show. Let's set it up. We want to say I'm terrible at 3D printing. I think that pretty much sums it up. Here we go. I'm terrible at 3D printing. I mean, it's absolutely awful, right? Let me see. Let's get a light in here. This one is particularly spectacular. Look at that gob of filament. Filament is what the kids call it. So I needed a way to contain all of my pieces, and you'll notice that I have a little 3D printed platform that everything is sitting, or on which everything is sitting, and it is all cleverly arranged. But I wanted to talk about the process of getting from a mess of stuff just on my table scattered about into something that is beginning to look actually like it was designed and is supposed to look this way. So here is my 3D printer at work, and this is me beginning the process of prototyping a container. And I am not great at visualizing things without actually holding them and seeing them. So I guess, I can't see it in my mind without seeing it with my eyes. And in order to see it, that's one of the beauties of 3D printing. You can actually have an idea and then print it out. So I printed it once. I changed the shape. So I printed it once. Here's the first printout. But the stuff didn't fit in the little holes. So then I printed it again, and you can see here the print is actually starting to fail. I have a little bit of stuff sticking up, so I added a raft. Let's see, I have more of this. Here's some of my failure prints. Here's a print with a little bit of a raft, and a raft is a little piece of, or it's actually a layer of filament that you print directly on the bottom to give your print something to stick to. And I had repeated failures, just failed over and over and over again. And that has been kind of my modus operandi when it comes to 3D printing. I have tons of failures as I try to just get something to stick. And one of my problems was I was printing with a material called PETG, P-E-T-G, PETG. It's like a little bit tougher material than traditional PLA, which is the bog standard printing material. So eventually I switched from my PETG back to PLA, and that's where I got the gold filament out. PLA for me is easier to print. I just haven't mastered my PETG printing. There are so many knobs to tweak when it comes to 3D printing. You can print it faster, you can print it slower, you can print it hotter, you can print it cooler. But what you see on the screen right there is actually what is on my desk right now. So if I go back to the webcam, that is what is holding all of my components. This is where I started. This was actually a really good print, and the edges looked good. It did curl a little bit in the corners. I'm not really. Can anybody tell me how to stop that happening in my Pet G? I don't know how to make this stop, please. And from there, we really hit the skids. We went downhill. So we ended up with stuff that looks like this, which is a hot mess. Stuff that looks like this that just curled right up off the bed and then kind of came loose. And as your prints curl, they will detach themselves from your print bed. And once your print detaches itself from the print bed, it's ruined. It just can't stay still. I got a second pretty good print. This was printed with what is called a RAFT. You see this little edge of filament around the main object. That RAFT is designed to allow the print to stick itself down to the bed a little bit better. And this corner, I did do a little bit of research. So this corner is potentially curling because the bottom layer is cooling too fast. And that causes the Pet G to curl up. Let's see, can I get my fingers right? Curl up like that. And that's bad. You want it to stay flat on the bed. And the RAFT is supposed to make the bed a little bit more adhesive to prevent that curling. But the RAFT also creates its own set of problems. It's kind of big, and it's a lot of filament to just kind of waste on your print. And it's a little bit difficult to remove. It just all gets really stuck together. I also had a bunch of stringing. This is these little strings of filament. I did read that Pet G is really bad about stringing, and I'm not sure how to correct that. There's again, tons of knobs to turn with 3D prints. That's the downside of 3D printing. The upside is you can just prototype different box shapes and different containers or just different objects and get them in actual physical meat space to look at, which I absolutely love. That is the only way that I am really successfully able to prototype. So last time we did some woodworking to do our enclosure, but this time I thought I would try some 3D printing. So this is just a flat board or flat kind of base, and in this base are these little holes, and the holes have been designed to fit the boards. The big thing I love about being able to prototype like this is that I can put it in my board, look at it, decide that I don't really like the fit of something, change it, and then print it again. So what happened when I printed all this out and set it into this little board, I realized that I have things arranged a little bit awkwardly. So I have my power up here at the top. So I have two different DC to DC adapters for my wireless subwoofer. Down into my Raspberry Pi, over into my DAC. This is my subwoofer preamplifier. So that cleans up the high-end audio sounds and allows only the low-end audio to get into my subwoofer amplifier. Well, guess what? The power to my preamplifier comes right through my subwoofer amplifier, which that's not a great design because then you got power running right over your audio signals. Never good. So if you have any noise in your power rail, you're going to get noise on your speakers. And if you've watched any of my channel, you know that I hate extra noise on the speaker, and I spend a lot of time trying to get the power rail correctly designed and placed. That's a big deal. Like, where does your power go in your design? Because if it runs over something like an audio amplifier, then you're probably going to end up hearing the noise, and you don't want to hear the noise. You want to hear the music, not the noise. So I was thinking I probably need to move this over a little bit, move this up out of the way, move the Raspberry Pi over here. Also, I am experimenting with a different type of DC to DC converter. So Previously, I've used a ton of DC to DC converters that are non-isolated. And what that means is that the ground on the input side is also the ground on the output side. It kind of passes it through, and it doesn't isolate the input from the output. But what I recently purchased was an isolated DC to DC converter. It's this little itty bitty chip over here. Let me unplug my devices. Oh, I'm still here. I'm still here. I promise. I'm just trying to unplug it. Oh, a couple of other little design tweaks to make. But this is my DC to DC converter that is isolated. So the input is totally isolated from the output. And with this device right here, I think I can actually use the power out from my Raspberry Pi. So I think I can use the 3.3 volt lines of my Raspberry Pi to power my DAC, which has been definitely a no-no in the past because of you've watched it all. You know that the Raspberry Pi's power rail is super duper dirty. It is nasty. And you can hear it in the speakers as soon as you plug your DAC into the power rail. You can literally hear just the noise on the power rail. With this little isolated power rail, power to DC to DC converter, since the input is totally isolated from the output, the noise is not allowed to pass through. So let's look at the data sheet for this really quickly. S-1WR3. Okay, let's turn the monitor on so that you can see what I'm doing. So I found this little guy right here, a B05S-1WR3, a isolated DC to DC converter. So you put one 5 volt, or the 5 volt input creates a isolated 5 volt output. Okay, so right out of the gate, I made a mistake. I ordered the 505 1WR3, which is a 5 volt output, but I needed a 3 volt output because my DAC chip, my PCM 5012, this little guy right here, it wants a 3 volt output. So I did a little experiment and I ran the 3 volt line from my Raspberry Pi into the input side of my isolated DC to DC converter. Then I used my handy dandy multimeter to measure the output, and it was also 3.3 volts. I didn't think that this guy would be able to boost the voltage anyway. It's pretty sure just a couple of transformer windings inside if we were to like cut it open. So if you put 3 volts on the input, you get 3 volts on the output, which was good since I had the wrong part and I needed 3 volts. So that actually worked. And the output rail is super clean and creates a nice solid power rail for my DAC chip. Now, one thing about these isolated, let me move my 3D printing nightmare out of the way so it doesn't hit my mouse. One other thing to note when using one of these isolated DC to DC converters is that they cannot actually output much current. You'll see that this little guy can output a maximum of 200 milliamps, which is pretty low power. You would not want to use one of these chips to try to power a audio amplifier. It just does not have enough juice. For the DAC, though, let's look up my PCM 5102. Let's see what is the power requirement of this animal right here. Pretty sure it's low. Here we go. The 5102A. In here, somewhere, power supply recommendations, there's going to be a maximum current draw. If we go to the data sheet, we are looking for amps. That is what we are looking for. We are looking for amps. And you know what might help is if I zoom in a little bit so that we can all actually read it. Because if I'm looking at it and I'm squinting on the screen of your phone, you really have to be squinting. It's crazy. Okay. I have absolute maximum ratings for voltage. Does it have an absolute maximum rating for current? Let's see voltage. The amps, and this is in microamps, which is a good sign, because if my power rail can only supply milliamps, then having something requiring microamps is good. Okay, here we go. Power supply requirements. Let's see, the maximum number I see here, 16 milliamps. 32 milliamps. Oh, now we're getting a little bit high. 185 milliamps. That is the absolute, or 187 milliamps is the absolute maximum. And our DC to DC converter can supply 200 milliamps. So we should actually be good. We should be in like Flynn. It's excellent. Excellent news. But that is because I'm only using it to power the DAC. I'm actually using a big old different power supply to power my amplifier board, which is fine, I just really need to keep that Raspberry Pi off the power rail of everything else in my system, because it will just create just a ton of noise. Now that I'm using this little chip to power my DAC, I have an extra DC to DC converter, this LM317, or I could use another one of these little PCM. What is this? This is the MP, I think it's the MP1584. Is that right? Yes, MP1584EN, so I could use another one of these. Anyway, what I'm trying to say is, when we looked at our amplifier data sheet, that is the, I think it's the TI3118. Is that right? Pretty sure that's right. Oh no, TPA 3118. There we go. I mean, come on. I should probably bookmark these. But this is the amplifier that we are using. And right now we are powering it with 12 volts, but that doesn't allow it to reach its maximum power. You have to use 24 volts to get to your maximum power. So with that in mind, I purchased this little guy right here, this little Meanwell RS124. It's a 100 watt, 24 volt power supply. Yay! But all my DC to DC converters are set up for 12 volts, and I need to set them up for 24 volts. Also, this preamplifier wants 12 volts, so I need to convert this 24 volt power rail into 12 volts. So that's going to be down the road, getting all my power rail straightened out. And while I'm straightening out my power rail, I kind of want to reorganize this. So let me show you the tool that I used so I can embarrass myself on YouTube here. With the tool that I use to do my 3D printing prototyping, Tinkercad. You'll notice that we also have a dollhouse. Lil G, the junior O-scope wizard, is working on a slingshot. And I have my wireless subwoofer box. Oh my goodness. Well, here it is. I like Tinkercad. I know there's, much more professional CAD tools, computer-aided design tools, But Tinkercad is so easy that I can work with it and not have to spend hours and hours learning it. I can just make things happen. So here is my box that I kind of have morphed into, and you can see this box that we're looking at online is actually printed out right here now. There are some problems. There are like right away when I printed this, I could see that the outside walls were too thin. They're super thin and so have just no structural integrity. And these little posts are going to be kind of wire guides to allow my wire wrap to kind of basically keep my digital lines away from my power rail lines. This wire guide was too close to this wall, and it snapped off when I was trying to kind of cut some of the stringing out from the inside. But, you know, I've reorganized this, so now that I have it, my preamp sits here, there's going to be a DC to DC converter sitting here, and then my amplifier's up here, so my 12 volt or 24 volts should all stay over here, and then my Raspberry Pi sits way up here away from the audio chain. Hopefully kind of keeping the noise to a minimum. But if I get back into Tinkercad, we can actually look at what I've been doing. So this shape is a combination of tons of shapes, and that's kind of how all CAD works. You start with simple shapes and then start adding more and more shapes, and then you combine them all and you make more and more grandiose designs. So this started out with just a simple box, and then I made holes, but underneath I actually imported a model of the Meanwell power supply, thinking that eventually this top enclosure will connect to some kind of second enclosure that will go around the power supply and allow me to kind of sandwich them together and somehow attach them to my actual subwoofer in a bucket. Either screw them to the lid, put them in the bottom. I do need access to some of the knobs of the preamplifier, and mainly the volume and the filter knob, really just at the beginning to kind of set it all up. And then that could be put away into the side. I'm a constant tweaker though. If there's a knob, I'm going to turn it. So I'm not sure how that's going to go, but I want to make a box. I want to make a box. I want to make a box. Let's look at what goes into this. So if I start into Tinkercad and I ungroup everything. So first of all, I want to take this power supply model and I want to hide it. I just want to kind of hide it so it's out of the way. And then let's take a look at everything that goes into this box. So here is the first stage. I have a bunch of holes that represent the different components in my design. And I can move these holes around, and I have printed them enough to know that these holes will actually fit the board. Now I had to adjust these holes about 10 times before I got them perfectly around the boards. I do have a micrometer, and I actually did use the micrometer to measure the stuff on the boards, or to measure the dimensions of the boards. I'm not a mechanical engineer, so I don't understand tolerances that well, but you needed more and more tolerance. And you don't want too much extra space in the hole, but you want enough space that my printed circuit board can fit snugly into these little spaces and they don't move around. And I was thinking I might use just a dab of glue or something to hold them in. I also thought, some of the boards actually have screw holes in them, so I could put screw holes into my design. That feels like next level stuff for me. You can see the level of detail I'm able to work with. But I need to make these outside walls a little thicker, and I need to do a test fit with the one that I've printed now just to see how the wires kind of work through the system. Again, I said that I have to I have to hold things to really understand how it's going to fit together. I just can't do it in my mind. I don't have that skill. That is a wonderful skill to have. I don't have it. So before I print this again with tweaks, I'm going to put everything into this container. I'm going to run some of the wires through to see how it all fits, and then kind of go from there. So, what we can do right now is pull all this stuff out and start moving it over into this box that I have printed up and just see what it looks like, which might be kind of cool. Another thing that I need to do is, let's turn the camera so you can see me, is kind of figure out what I'm doing with my Raspberry Pi endpoint here and Logitech Media Server. So on the last episode, and a couple of episodes before, I've talked about Logitech Media Server, which is the server software that I am using to move music around. So get music from my phone or device out to the speakers, which I have some speakers on the desk right here. So I have a speaker right here, and then I have my subwoofer down. Where is it? There, down here. Here's my subwoofer over here. So I need to get the music off my device and into those speakers, and I was using Logitech Media Server because that allowed me to wirelessly synchronize different devices, but it doesn't work 100% of the time, especially from Spotify, which is my main streaming service. So I need to do a little bit more research on how to make a more stable connection. And I also need to figure out how to turn the amplifier off when I am not using it. So how do I utilize the mute function of my amplifier? Both of my amplifiers, the one in the subwoofer and the one that we made before, have mute features that can work. Now, do they work? Only if I wire them up and program my device to actually use that feature. And I think Logitech Media Service allows me to do that. Okay, so right away I can see a mistake that I made. I made the holes for a lot of these boards a little bit too deep when I printed it. You make mistakes right out of the gate. Everybody makes a mistake, and that's okay. That is the beauty of rapid prototyping. Fail fast, and then just fix it. Don't worry about it. That's why we're prototyping to begin with. We're trying to see if things just fit. Okay, so I have my amplifier board here, my DC to DC converter here. I'm going to switch it out. I have a different DC. It's the same DC to DC converter, but I've just connected the pins a little bit differently. Raspberry Pi here. Actually fits. That fits pretty good, actually. Now I need my DAC. My digital to audio converter goes here. I think it'll actually go like this. Oh, now I'm realizing. So if I put it like this, it is close to my preamplifier, you can see. I have some holes that I'm hoping actually fit. This is the reals test. I have walls now and holes in the wall to try to fit these knobs. Y'all are about to see me do a test fit for the first time. We'll see how good this fits. Oh my gosh. Does it fit at all? No. Look. It does fit, but I need more. Oh, I need more space on these holes. These holes are like tight. They're not light tight. They are tight around the knobs. Ah! So I messed that up. That's okay. That's why we're prototyping. Okay, so that goes there roughly like that. Need to make these holes bigger. And then I have a spot for my DC to DC converter for the 24 volt to 12 volt from our preamplifier. That fits well. And finally, I have my little isolated DC to DC converter that hopefully is going to fit in this little hole right here. And it does. It does. So we have our layout roughly like this. That feels pretty good, you know? I'm noticing that with the DAC pointed this way so that I have my audio signals directly into my preamplifier input, the power is on the bottom, and the power is going to come from the Raspberry Pi. And I actually want the Raspberry Pi like this, so I don't want this power signal to go around my audio signal. So I'm not sure how to route that. It's a good question. I might need to actually, if I do it like this, if I do it like that, then my audio signals would still cross over my power signal. The beauty of 3D printing is that you could just make a real quick change. So for instance, if I wanted to change the way the DAC is sitting in there, I can go back to my Tinkercad software and I can select the hole that represents the DAC, this guy, and I could rotate it. So I could say, hey, let's rotate it 90 degrees. Now I can see that, oh, this is going to be in the way. I probably need to ungroup some of these things. So let's take this post, let's delete it, move this over so I had a little bit more space. So now the audio output could go from the bottom side of my DAC over to my preamplifier. I can also go over here and ungroup this. And I know that these holes need to be a little bit bigger. So how can we make this hole a little bit bigger? I could make it that, like that, and that's a slightly larger hole. I'm sure there's probably an easier way to do that, but that's why I'm using Tinkercad, because I'm just not the greatest CAD artist that there ever was. I'm going to undo that because I'm just not sure exactly if that was the right move. Anyway, you can see where we're at. We're still prototyping the container. We're trying to get everything arranged inside of my container and then eventually attached to this power supply, kind of sitting on the top. So I'm thinking there's going to be a lid that kind of goes around the edge of the power supply, and then the other part sits on the top. Or really not a lid, just a whole box that probably goes around the whole power supply. And all of that will go into some sort of weatherproof container that I will purchase, because I don't think I can print a weatherproof container. I'm not sure. I'm not sure that's me. I don't think I can do that. I don't think so. Next time, I'm not going to be doing 3D printing. Hopefully that'll be all done off camera because I'm so bad at it. I hesitate to show you guys I don't know why. I don't know why I should be embarrassed about that. I'm not embarrassed about like failing at electronics, which I'm supposed to be good at. But it's kind of boring to watch somebody just CAD if they're not great at it. It's just I'm going to print out some more boxes. I'm going to get this thing at least laid out inside of the box so that it can get sound out and connect to this new 24-volt power supply. And I also want to experiment with how to control the amplifier turn on and turn off with Logitech Media service, with the service running on the different devices. And that is going to prevent unwanted noise from exiting the speakers, because unless there's music playing, there would be no sound coming out of the speakers because the amplifiers would be turned off. Also, it would save tons of power. That's how my previous amplifier design worked. And I had to write a little Python script that ran as a service. I don't think I'll have to do that this time. I think I can just use the services that are already built into the software. So we're going to explore the software a little bit more, see if we can control our hardware with the software as it's made. And eventually, we're going to put all this in the driveway and make some beautiful music. That's the hope. I don't know all the nerds in the world, and I would love to meet them. So please share this with a nerd in your life, and I will see you guys next time when we do a little bit more nerding out together. Later. Bye.